Imagine the first sign isn't a shadow, but a distortion. Looking up, the night sky begins to warp. Familiar constellations bend. Distant stars appear in duplicate, their light stretched into ghostly arcs around a growing patch of absolute blackness. This is gravitational lensing, the first calling card of a black hole. For its gravity to start affecting us, a stellar mass one, say 30 times heavier than our sun, would have to drift inside our solar system, somewhere past Neptune, but now it's closer. Earth's orbit around the sun wobbles, then breaks completely. We're no longer tethered to our star. We are captured, pulled onto a new one-way path. The initial journey is a slow, inexorable drift into darkness, but the forces acting upon our world are building, preparing to tear our planet apart from the inside out. Every single day, the black circle against the stars grows larger. The pull isn't uniform. The side of Earth facing the black hole is yanked with unimaginably more force than the far side. These are tidal forces, but not like our oceans know. This is a planetary-scale torture device. The ground beneath our feet heaves.
Earth's crust cracks open, unleashing supervolcanoes and global earthquakes that shatter continents. The very structure of our world fails. This process has a name: spaghettification. The planet itself begins to stretch, elongating into a thin planetary noodle. At the same time, the intense gravity and radiation from superheated matter spiraling into the black hole starts stripping away our atmosphere. The blue sky boils off into space, leaving a vacuum. Now, there's nothing between us and the warped, terrifying star field ahead. We see the void for what it is. Earth is coming undone. Our planet is no longer a sphere. It's a disintegrating stream of rock and magma accelerating towards the abyss. Recent observations have confirmed a plunging region around black holes, a cosmic waterfall where matter stops orbiting and simply falls. We are now in that waterfall. And here, physics gets truly strange. According to Einstein, time itself begins to warp. For anyone on the remnants of Earth, a minute might still feel like a minute, but for an observer far away, our time has slowed to a crawl. As we fall, we could watch the universe outside fast forward.
We'd see stars born and die in seconds. Entire galaxies would wheel across the sky in what feels like an afternoon. Any message we tried to send out would be stretched into an impossibly long wavelength, red-shifted into silence. We are completely, utterly cut off from the rest of cosmic history. We're approaching the event horizon, the threshold from which nothing, not even light, returns. From our perspective, crossing it might be anticlimactic. No wall, no gateway. We'd just slip past the point of no return. But to anyone watching from a safe distance, we would appear to slow down, freeze at the edge, and fade over an infinite amount of time. Our light, our last signal, forever falling but never arriving. What was once Earth is now a stream of fundamental particles spiraling toward the singularity at the center. The information paradox asks, what happens to everything that made us us? Is it destroyed, violating the laws of quantum mechanics? Or is it somehow preserved in the faint hiss of Hawking radiation? This destructive journey, this ultimate end, forces us to confront the biggest questions we have. The atoms that built our civilizations and our mountains don't vanish. They become part of the universe's greatest mystery, feeding an engine of space-time that we are only just beginning to understand.